Hello, everyone. Hope you have a lovely night tonight. Let me quickly introduce our presenter, Mr. Wang, today. Mr. Wang is currently a teacher in a very top private girls' school in Turag, which ranked the highest among Melbourne's girls' school for VCE in 2021. Previously, Mr. Wang taught secondary maths at Melbourne Grammar, helping many students to achieve perfect VCE math scores, leading to his students giving him the nickname smartest math teacher, not one of. Mr. Wang has also tutored students in Victoria Mathematics AMC competition, and he is a regular tutor at Melbourne Grammar School and Scotch College. In addition, he is one of the only 25 VCE examiners for specialist maths in Victoria. Thank you, Ms. Wang. Your turn.
Oh, do I start now? Okay.
Yes.
Thank you for the generous introduction. I'm not quite sure. Am I the only 25 examiners? Probably they have more than 25 examiners in specialist maths taking exam. Maybe I actually can't remember, maybe 30 of them every year. But I have been marking specialist maths exam too for the last 12 years.
His life right now.
Okay, so now I was asked to talk about the VCE mathematics changing beyond 2023. Okay, so I just I have looked at all those the study design. The VCE study design you can readily available from online. You can find this study design for 2023. You have, but I'm only talking about the methods and the specialists today. So I have sort of highlighted some of the change in methods. As I said, I'm not quite sure if anyone can see this document. Olivia, can you see this document?
Yes, I can.
Okay,
Perfect.
all right. So I'll just quickly talk about this. Change in methods is very small and insignificant. The following are the changes. Basically, this is the VCA give us the briefing. Okay, I just cut paste all this. So the in unit 1 in methods, they say content that can be omitted. So that means you can omit this. You don't have to teach this, but you still have if you want to teach this, you can still teach this. So we're talking about a vertical line testing to determine whether a relation is a function or not, and this is not going to be tested. But I guarantee every teacher will still teach this. We're using vertical line to testing whether this relation is a function or not. Or also, okay, so this is even not only vertical line, we were using horizontal line to testing whether this function is a one-to-one function or not. Even they are not on the study design, but the responsible teacher, experienced teacher will still talk about this without doubt. And then we're talking about matrix transformation is out. But a matrix, operation of matrices basically is, if this is out, matrix operation will not be examined in any way in methods. But a matrix operation would be in further maths, which is now called general maths, and also specialist maths. Specialist maths, they reintroduce matrices transformation. They put this into a matrix transformation is in specialists now. Okay, so that basically is out of methods, but in specialist maths. So this is basically unit 1. Non-function relation, they basically you don't have to mention this, but the teacher was still talking about this relation: one-to-one relation, many-to-one relation, one-to-many, many-to-many, all those relation. And the only one-to-one relation and many-to-one relation would be function. They still will be. We will still be teaching this in the new year, but they are probably will not be examinable. Okay, they are not going to be in the exams. Okay, but to try to deeper understand the function, the relationship between relation and a function, we still teach this anyway. So this is unit 1. And unit 2, so this is quite bizarre. They say the first principle of differentiation of polynomial, first principle is out. But that doesn't mean when we introduce a derivative, nobody can ignore first principle. The only thing I guess is they don't come up with those questions by sort of like using first principle to derive, let's say, fx equals 5x squared plus 3. Okay, so we're talking about the first principle differentiation of a polynomial. We will not ask you to use first principle to derive a polynomial function, the derivative of a polynomial function. But we just ask you to using formula to do it. We give you a formula to do it. So basically this is it. So the first principle will not be tested in the exam, but I guarantee you every teacher will still talk about the first principle. Otherwise, what are we talking about? The derivative. Derivative is the instantaneous rate of change. So we'll have to start with average rate of change, then become those 2 points becomes so close, then become 1 point, and then then they become a tangent. So then they become instantaneous rate of change. So it initially was the chord, the average rate of change, they become instantaneous rate of change. Then we define instantaneous rate of change as a derivative. So that's basically the first principle. So we will the concept still will be taught, but those exam question, those asking for using first principle to derive the polynomial, those type of question will not occur in the exam anymore. So that's basically the difference. Okay, so that's the methods. So that's a very small change. Basically, the main change is first principle will not be tested. The matrix transformation is out. So because if you look at past exam, let's just look last 5 years exam, 1 or 2 specialist methods exam, 1 and 2. Transformation is very heavily featured, and matrix transformation is very heavily featured. Even this year, they have matrix transformation in the second exam as well. One of the probability question, they have this matrix transformation. But the next year, the transformation is still there, but they are not going to use using matrix to do transformation. But now, but this become in specialist. Okay, so now we're talking about a specialist maths. So the specialist maths, the change is enormous. So I cannot emphasize enough. The specialist maths has a huge change. The course becomes so huge and so big, and the degree of difficulty is increased as well. And then if those people who are familiar with IB high level and New South Wales extension maths, so if we familiar with those 2 sort of maths exams, so you compare to our specialist maths. Traditionally, New South Wales extension level 2 maths is a lot harder than Victoria specialist maths, and also the international baccalaureate high level. So high level, they cover more stuff than specialist maths do as well. So however, after 2023, our course, the VCE specialist course, will be very much similar to New South Wales one and also international RD. So we're adding lots of stuff. We're adding actually more stuff than the New South Wales, some of the stuff. So basically, if you look at this, the VCAA, this is the VCAA recommendation for specialists to unit 1 and 2. So the unit 1 and 2, they have a number system. Okay, now this is the older one. We don't have to worry about it. That we already talked about this. The graph and non-linear relation, this is old as well. So logic and algebra. So this is new. They added this in, okay, it's unit 1 stuff, but lots of school doesn't teach this in unit 1 and unit 2, but they will teach in unit 3 and 4 next year. But they are still relatively easy. Logic is still relatively easy. The geometry proof is already in there. It's not new. The new is the proof. Okay, so now if we look at this logic and algebra, so basically inside they have a proof as well. Now this is brand new. The proof we're talking about, the major thing to prove in added specialist maths is induction. Proof by induction will, without a doubt, will come up in next year's exam. And proof induction in induction is always coming up in New South Wales high-level exam and also IB high-level exam. So proof by induction is without any doubt will come up in the exam next year. But the other proof, whether they will come up or not, we don't really know. But the plane geometry, whether they are coming up or not, we don't really know, because the geometry proof is always in the course, but they never come up in the exam. And also vector proof, they are in the syllabus. They hardly ever come up in the exam. However, this year, Specialist Maths Exam 1, which we did Friday, first exam, and we have one question to prove two vectors perpendicular, which is the plane geometry, is the angle subtended on the diameter. So this is a 90 degree, but they want you to use a vector to prove. I can show you this question later on if anyone interested. So this year, so they're already in the exam, but they are very seldomly come up. They don't come up very often. Plane geometry never come up in Specialist Maths exam. But now we introduce proof. This proof is not limited algebraically, a sort of manipulation proof like induction, Conti sort of example, or those sort of proof, or direct proof, or indirectly proof, or whatever. So, and nobody actually knows what sort of proof question will come up next year, but induction will definitely come up. So then the try questions and exam will be published. We were told by VCA will be published in next year, early next year, when the school starts, probably in February. So those type of, they also, they were told, because I know some of those examiner markers, they writing those try exam question. They were told, do not write hard questions. Write those mediocre average sort of question, because they don't want to scare all those students and the teachers if you write some hard questions. So therefore, if next year, if those people see the example questions, they are average. If we're talking about the degree of difficulty, they are average, very average. So they are not hard. So when, as a teacher, we prepare those questions, those areas, whenever the example question we see, you would think, okay, so we're adding the degree of difficulty a lot harder, but this type of question will come up. So until we see the sample question, we will see more clear picture of what sort of proof question will come up next year. And also proof question is very difficult to teach and difficult to mark as well. So that's why I'm thinking induction will be first introduced, because induction have a very clear structure. You have 4 steps where n equals 1 is correct, or n, assume n equals k is correct. Then you have to prove n equals k plus 1. Then you have a conclusion. You cannot skip any steps. 4 steps you have to follow. The most important step is step 3, when you have to prove when n equals k plus 1, this equation is correct. So those type of questions, it's easy for marking this paper as well, easy for teacher to marking those as well. So proof by induction will definitely in the exam next year. Then if you look at this simulation, this is talking about the probability, which is, we will do this in unit 4 anyway. So graph theory is new as well. So then this one, nobody knows what sort of question will come up. So graph theory here is very much look like a further maths. So next year we call them, not called further maths anymore, called general maths. So very much look like a further maths, the graph theory. Like we're talking about a Hamilton path, Euler path, all those sort of very tedious concept. But we don't really know next year whether this will come up in the exam or not. But no teacher will afford not to teach this topic. So in personal sort of, in my school, current school, I teach them this year. So we go through as quick as possible. We're simply using further maths notes. We simplify the further maths notes. Then we go through very quickly. And the students will understand what, especially the terminology. Then next year, simply we don't have time to cover this anymore. So this one is a question mark. So we will see next year the sample question, what sort of depth they are going to sort of into this area. But they are the concept is very simple because they are in the further maths. So we question the lots of teachers, current teachers question why we put this into specialist maths. How do we examine this topic? Are we examine this topic exactly the same as further maths? So what's the point of this? So or we make it a lot harder. So we're talking about graph theory. You can make it a lot harder, graph theory. And also they're talking about it when they're talking about the graph theory, they even talk about the programming. Okay, a pseudocode. They might come up in next year's exam as well. So which program they sort of we're talking about algorithmic sort of pseudocode. So we don't care which program you're writing. So we have to understand those flowchart and those algorithmic sort of thing, which is in the new textbook. The new textbook, by the way, 2023 for the specialist maths is already out. I have the copy of at least one published, which is the Cambridge published, and they have the graph theory there, and they have the pseudocode as well. So those flow chart, whatever. And then we do have to, if you haven't teach in year 11, because personally I didn't teach in year 11, I have to teach them in year 12 because we don't, currently we don't have a book. The book is just out. Okay, so then we will teach this next year, but they are not extremely difficult, but still need time. And the vector is the same thing. Transformation here, as I said, we introduced matrix transformation in specialist maths. They never tested it before, so because this is in methods, but now they are in specialist maths. So everything about matrices is in specialist maths. Now this is 1-2. So 1-2 basically for the foundation of the 3-4. And we were told the specialist maths next year, the first exam, nobody knows what sort of question will come up, but we were told eventually specialist maths exam will cover both year 11 and year 12. Even some of the content we don't teach in year 12 will still be on the exam. Okay, so this is kind of like an IB international course. We examine 2 years course instead of the current. Sorry. Hello, is there any questions? Oh, I'm sorry. So I'm just saying currently is specialist maths. Basically, we only on those questions, most I would say 99% of them will be only testing your unit 3 and unit 4. But later on, after this year, the specialist maths, because the content is just so much, we cannot finish in unit 3 and 4. We have to spread around to unit 1 and 2. So the exam will cover 4 units. Okay, so without any doubt. Now let's have a look at unit 3, unit 4, the area. This is again the VCAA give us the content. Discrete maths, basically. They say discrete maths is so huge. The topic is so huge. They're talking about a graph, theory, logic. All of them are discrete maths. Okay, so then the function relation graph. This is old. Algebra, number structure, they're old, so they talk about a complex number. The calculus, now we're talking about the new stuff is in calculus. We next year we're adding more stuff. We're adding integration by part, which is always in the high level IB course and also in New South Wales high level. But we never been in the specialist maths, but now we're putting in integration by part. So that's another sort of skill for integration. Okay, so and then we not only this, we're adding the surface area. Okay, so instead of we talking about rotating the volume from x-axis or y-axis, then we're talking about rotating from x-axis, rotating from y-axis, the surface area. Okay, so currently we only do the area the area we are doing is in 2-dimensional, but next year we will do the area 3-dimensional. So the surface area formula we will introduce. This is the extra stuff. So those are the integration, 2 extra stuff. But you might think, oh, there's only 2 small stuff you add in. But by adding integration by part, the integration the question on integration becomes so complicated and can be made very, very difficult. If anyone's familiar with New South Wales exam, if you look any year's exam, their exam is very difficult on integration by part. You using this technique, so the question becomes so complicated. Okay, but I'm personally very, very in favor of this integration by part, which is make math more fun. And not only this bit is a change. You're adding two new things, and space and measurement. You add in lots of new stuff, which is we're talking about the vectors in here, the space. So people talking about space measurement to involve two-dimensional, three-dimensional. We're talking about the vectors, sine rule, cosine rule, vector in three-dimensional. Not only this vector in three-dimensional here, and the vector in vector calculus will be part of this course as well in here. And now in here next year we have more. So currently, specialist maths, we're only talking about, for instance, vector, we're talking about a product, a dot product, the multiplication. But the next year, we will do cross multiplication, so become more complicated. So we're talking about, let's say, matrix times make 3 by 3 matrix multiplication. Two vectors do cross multiplication become third vectors. Okay, the product become vectors as well. Currently, we only do dot product. So dot product to two vectors multiplication become a scalar. So simple. It's not vector. But then we do a cross multiplication. So two vectors multiplication become another new vector. So this has more application and more sort of complicated stuff we will learn next year. And then so it for the consequence we were using normally currently we're only talking about a line equation of line. We're talking about a two-dimensional, but the next year we're talking about equation of line. We're using three-dimensional. Line is three-dimensional, or we're talking about a three-dimensional plan. Okay, so that's a lot more sort of stuff we're going on, and then with line going through the plan or the angle between a line and the plan, all sorts of the stuff of question will become more complicated. So here there's a lot more stuff which is not in current textbook become new. So in those two, so basically up to here, so we discrete method, which is the proof, all those sort of thing will be there. And the calculus, we're adding integration by part and the surface area. And in space and measurement, we're talking about a vector in cross multiplication in terms of vector. So then the implication is the application is becomes so huge, and the question become, you can make lots of new question and complicate the question and harder the degree of difficult. I mean, degree of difficult really it's up to you, the examiner. I can make we can testing this concept to make we design a very, very easy question, or I can design a very challenging question which require a high level of algebraic manipulation skills. So it really depends. So nobody knows. But the last topic, data analysis probability, they are exactly the same as currently we are doing. So we're talking about the sample, the simulation orders. So they are exactly the same. They are not new. Okay, so this is the basically this paper is VCAA give us, okay, the advice to us, and this is basically the topic we are going to do year 12 methods. So we're talking about those 4 areas are very boring. This is still same: function relation, function graph, algebra, calculus, probability, and statistics. This is methods we haven't changed. Specialists, we have 6 study area. And then sort of function graph, algebra, calculus, vectors, mechanics, and the probability. Oh, I forgot to mention this in specialist maths. What I'm saying is we're adding lots of stuff. But what is taking out? Yes, we do have one thing taking out, which is dynamic. Dynamic has taken out. So basically, we're talking about Newton's 3 law is not in the VCAA specialist maths anymore. But we don't really know. But the kinematics is still in the new course. But when we're dealing with kinematics, inevitably will dealing with Newton's third law, which is F equals ma. When the force is changing, the acceleration changes as well. So this is inevitable, have a link between Newton's third law and the kinematics. But then the dynamic is out. So next year, we guess I have been talking to lots of specialist teacher, very experienced teacher. We all say we cannot ignore the Newton's third law completely, which is F equals ma. So because this is not in course anymore, so the exam question will simply tell you F equals ma, the new force, or they tell you A equals F divided by m. So the acceleration is changing. So therefore, as a teacher, I still have to, in class, I still have to talk about Newton's third law, just in case you give the brief background, a brief of those background to the students. So when the force change to an object, and then the acceleration changes as well. When acceleration change, then everything has to using calculus to do solving those type of questions. So although we take a dynamic out, we still have to talk about it. So therefore, as I said, specialist maths next year, the new syllabus is huge, is just enormous. Okay, so for I don't know who is listening in here, if you're students or if you're maybe your parents or whatever. So whoever, if you committed for specialist maths next year, you need without adding those stuff is the most challenging subject. Then we're adding more stuff. So without any doubt, this become the most challenging subject in entire VCE. Currently, you can see the markup, the specialist maths. If you get a 40, you mark up to 51. So they mark up huge. Okay, so if you get a 35, mark up to 46.7. So this is had huge markup. The reason is being this subject is very, very difficult. So, but for next year, and this subject become even more challenging. So the content we cover is even more. So therefore, the students has to commit. What I tell my current students is every day you have to spend 1.5 hours. We're talking about 7 days a week. If you don't spend 1.5 hours, you simply haven't gone through enough questions. If you haven't gone through enough questions, you will not be efficient when you do sit for the exam. You can't finish it because every single question look foreign to you. You look very strange to you unless you spend this amount of time, and then you will do well. And so also my advice to the specialist students is you obviously have to love maths. Once you love a subject, you actually don't realize you actually already spent 1 hour or 2 hours a day. You don't feel it. If you don't like it, then you have to, someone wants you to do well, you have to force yourself to spend 1.5 or 1 hour, 2 hours a day in specialist maths. That's a torture. Okay, so therefore, my advice to all those students trying to do a specialist maths next year, or even this year, whenever this year is already finished, you need a commitment. Not only commitment, you have to love maths. You have to enjoy the manipulation of those algebraic manipulation. You enjoy the content of those maths. So you're basically curious of the nature. All those famous theory, why does theory where this theory come from, where's the application. If you don't enjoy those sort of thing, I mean, it's very difficult. Okay, so as I said, now this is I cut paste from this website. And I can tell you this website. If anyone wants this website, I can give you this website as well. So I can actually show you this website as well. So this is someone as a current teacher developed this website. Now let me show you this website. I'm not quite sure. Am I share? So let me share this again. Okay, so this is the website. Okay, I'm just okay. Olivia, can you see this?
Yes, I can. Perfect.
Thank you. Now this is the VI's Victoria Maths Notes. This is everyone can see it. So they have a more scope, more stuff. So look, this VCE, they will give you, if you click VCE's Year 12 Specialist Maths, they tell you this is the 6th study area. And you actually can click this here and see what topic they are doing. And they actually have a very detailed topic one by one. Okay, so they have, for instance, the graph of here. So basically they're talking, they list all the topic which is from textbook, absolute value, composite function. Okay, so orders. Okay, so reciprocal of function, all of those, and they also have a technology sort of a hint as well. They give you TI Inspire or Casio, two different calculator. They give you a little bit of sort of hint, the quick way to do it. So this is the first area. So now, so then you can go through all of them. Okay, so look at study twos, study area twos, algebra. You have complex number of also. They have everything. If you click this in, so they will show you some kind of 1 or 2 pages of those basic stuff, very basic stuff. Obviously, if you rely on this website to study, obviously it's not enough. But the reason I'm showing you this is basically if you want to see the more detail. Now, this is how many topics we go through, all of them. Okay, there's all of them. So look at this calculus, for instance. Okay. The differentiation, whenever second derivative, rate of change, implicit differentiation, and they say logarithmic derivative is optional. This is wrong. There's definitely not optional. Log derivative is in as well, and implicit second derivative is in as well. So they have all sorts of this. Okay, they integration by part. I don't think they put integration by part. So they probably haven't updated yet, but that's all. So differentiation equation. So in talking about the calculus, the section is huge, enormous. Okay, so not only we do derivative and we do antiderivative. So derivative involve a lot more compared to methods. We involve circular function, inverse sine, inverse cosine, inverse tangent, a lot more. And the integration is the same. So we integration in a lot more. So the technique of integration in here. So then we're adding integration by parts as well. So there a lot more. So all the methods, approximation is always there, and then that's kinematics is in there as well. So kinematics is still there. Dynamic is out, but the kinematic is still there. Okay, so that's calculus. Then the vectors. Okay, so you have lots of them. They already put those vector proof of those. Okay, lots of vector calculus, all of those. Okay. And then the mechanic, so still there, but the dynamic is out. And the Newton's law, they are out. So some of those are out. Okay. So study area 6, the probability, and that's the same as this year. Okay, so this is basically the same as this. Not only we're talking about the example distribution, and then with hypothesis sort of testing, very big. Every year, the last question. Second exam, which is tomorrow, we have 3 o'clock, start at 3 o'clock to finish 5:15. And the last question is always statistics, question number 6. And we're always talking about the hypothesis sort of testing and the p-value, all those sort of things. They are all very complicated stuff. They are basically relatively new to the specialist maths. I think it's only has been introduced for 5 or 6 years so far. But they are, if you look at those courses, they are seriously the university statistics sort of course, a very high level course, but they are simplified this version put into high school level. So therefore the concept is still very difficult. The concept. Okay, so lots of stuff, all of those stuff need calculus to prove, but we in high school level, we obviously cannot sort of prove for you. We just accept those conclusion one by one. Okay, so therefore make this topic even more complicated, because the students are not fully understand those concepts. We simply present the conclusion for you. Okay, so for instance, we're talking about a limit theorem. So every sort of distribution, if you have a more than 30 data or 50 data, then eventually the sample mean would be always follow a normal distribution. Okay, so the sample mean is always a population mean, and the standard deviation is the normal distribution divided by square root n. So those sort of theory we cannot prove for the students, but we simply ask students to accept this. Okay, so but it is to understanding. So it's kind of more challenging for students to understand this. So why? So why this is the case? But we simply cannot say why. We just tell you this is the case. If we want to say why, you need a lot more calculus to prove this, or all sorts of other things. Okay, now. I'm sorry, so the time is what, 8:05, so I have been already talking about 35 minutes already. So now, so basically what I'm saying is, so we go back to this page, the initial page I have. Let me have a look at this. Share, how do I share? My God, I forgot. Okay, so where's the button? Okay, let me go back to here. So basically, this is the change in VCE methods and specialist maths for next year. Then, as I said, if you want to see especially in the specialist maths, if you want to see detailed content, you can go through any website. So the website I show you is the VCE Maths content. If anyone wants a link, I can give you this link. This is written by one current math teacher, and so he obviously teach methods and special. He put it online, so which covers all the details. So otherwise, I can give you my sort of current the content as well, my school content, all the topics. Basically, I follow the textbook. So that's the detail. If you want to see, if anyone want to see the change of this, also available from, because we know the textbook, VC Victoria school using two textbook. Largely we're using Cambridge textbook or either Cambridge or Nelson textbook. So there's two textbook. Nelson publication, they put 1 hour a video sort of on YouTube. If anyone want to see those, I can give you the link as well. There's about 1 hour. So obviously they promote their book. The second half is heavily talking about their book, but the first half is okay. They're talking about the change in specialist maths. If you want to see it, I can give you the link as well. So you can, I will give those two links to Olivia. So if any parents or students want to see it, Olivia can pass on so that you can watch the video for the YouTube for the change, the detailed change for VC for specialist maths next year from Nelson publication. Okay, so now I am not quite sure. So is there any questions? If anyone want to ask any questions? How many people we have? Oh, we have quite a number of people, and we have a chat. You may send an email to us. Also, sorry. Oh, okay. Thank you. Yes, thank you. The two links we will. I will give those two links to Olivia. Then Olivia can pass on those. Then you can read, watch or read it by yourself. Okay, in your spare time. Any other questions? If anyone have a question, Olivia, is anyone have a questions?
Let me quickly check.
Okay, so they are all muted. You don't have to mute all of them. They can talk. Let them talk.
They can unmute themselves.
Oh, they muted themselves. Okay.
Yeah.
If they can, if anyone want to ask a question, you can ask. Okay, so. You can show your face as well. I show my face. Can you see my face?
Yes, we can. And basically, what are the purpose that they increase so much difficult levels into the specialist maths?
I don't know. The
It
only
seems a big
reason
jump.
I know the only reason I can think of is we are in par with New South Wales and international baccalaureate, international the baccalaureate. So
The IB, isn't it? IB system.
IB. So they are the same degree of difficult, because in talking about it historically, let's say with our students did a VCE here, specialist maths, then we go to New South Wales doing, let's say go to Sydney University or whatever University of Sydney Technology, and then compare both the maths. You have done specialist maths, and also in New South Wales they did extension level 2. They have done a lot more calculus than us. So they understood integration by parts, and we don't. Okay, so this is the trouble. Then the kids going there to do engineer course, you have to do a sort of bridging course. Otherwise, you can't understand. There's lots of topic. So that's my guess. I mean, ideally should be national. So this curriculum should be national. Every state, 6 states, should do the same thing. But New South Wales is always not both New South Wales and Victoria are the leading states. Like Tasmania basically copy our content, everything. They copy us, everything. And then probably South Australia copy New South Wales, everything, or they make it slightly easier. But in traditionally 2 states, New South Wales and Victoria, they're always sort of dominant states. But in terms of maths, they are slightly more challenging than us. So to me, it looks ridiculous if we're not as the same level as New South Wales. That's my guess. Okay, that therefore we introduce lots of new stuff, which is they're already here in IB and in New South Wales. Why not in Victoria? So finally they put those stuff in in Victoria now. So they make it slightly harder. Okay, but if then because I haven't been I've been in the system for 20 years, but if you go back, so I don't know the history. So if you go back, let's say 40 years or 30 years or 50 years ago, maybe Victoria, those content is all in the older syllabus. So who knows? In 30 years, they are called a different name. They call pure maths applied or whatever. They are all in there. Okay, those topics. But I actually don't know. So I have only been teaching in Victoria for 21 years. So that's all I have known. Okay. Time is very quick.
It is very interesting topic, Mr. Wang. Because last week when we talked to Mrs. Eunice regarding the English curriculum change, actually last 4 years we added one new style of writing because of New South Wales. They have this style of writing, but when the new curriculums changed, this comparative writing has been removed out. That Mrs. Eunice mentioned about 20 years ago, it looks like 20 years ago when she started teaching VCE English. The curriculums are quite similar to now.
Oh, okay. So they change. They always change. I know it's exactly it's a cycle. Probably 20 years ago they made a change. They made the specialist maths easier. Okay, that's my guess. Okay, over the year they watered it down. They're getting easier, and then all of a sudden they say, no, we can't make it easier. We have to put it more stuff in. So it's I don't know. Maybe in next 5 years they change again. Who knows? New South Victoria VCA talking about the maths is not good. Okay, so the people in charge of VCA, they constantly change. They're still different. For instance, VC only in Victoria we're using CAS calculator. No one in any other state in Australia using CAS calculator. New South Wales, their calculator cannot do algebra. They just do normal calculator, just do a log. They can do sine, whatever. It's just like a scientific calculator. You can't perform algebra. But our calculator is so powerful. You can do derivative, you can do antiderivative, you can do algebra, you can do whatever. So therefore, it is very weird system. The entire, if you look national, Australia, the states wise, they compare New South Wales to Victoria. We're only talking about maths. If you look at the calculator, a different calculator, using different calculator, obviously the exam paper will be written differently because if we're using this CAS calculator, which can do algebra, lots of questions become trivial. So I just one button, I can solve everything. So it is a very, very weird until the states has the same calculator, same curriculum, then we're talking about equal, but still there's a lot of inequality between the states. It's just amazing.
Yeah, talking about calculator, Mr. Wang, do you recommend, I mean, before VCE students, do you recommend the students practice when they're doing lots of questions? Do you recommend they can use calculator or
no, they don't. I don't recommend people before year 10 using any calculator. You just need to practice your algebraic manipulation skill. Algebraic up to year 10, you just need practice. If you don't have algebraic manipulation skill, but even we're talking about we can use calculator, but however, the VCAA still maintained exam 1 for both methods and specialist. Exam 1, we cannot use calculator, especially talking about exam 1 specialist maths exam. Full of algebraic manipulation skill. If you are not good at algebra, exam 1 you will never do well. Okay, so now having said that, I must show you the last year's exam, a couple of those questions, exam 1 in specialist maths, and also current exam 1, so which we did Friday, and I have the solution. Now compare this year's exam and last year's exam. This year's exam 1 is a lot easier. There's no not much complicated algebra compared to the last year. Not only last year, the last couple of years, the algebraic manipulation is not as complicated as last 5 years. We're talking about this current year exam. So now, first of all, I'll show you this. So if there's no people ask a question, I'm using the next 10 minutes to show you those questions. Let me have a look at last year's exam question. Oh God, let me have a look at this. So if I can find the last year's. There you go. So let me just open that up. Okay, so share this. Can everyone see the? Can everyone see the specialist maths?
Yes, we can see that.
Okay, this. However, sorry, I'm actually. This is in this. This is this. Oh my God! I cannot make it bigger. Okay. This is exam 2. I think this is exam 2 is not exam 1. Not exam 1. So this is exam 2. So I didn't have this exam 1. I didn't download. It's in my. I should sort of show you last year's exam 1. The last question is so complicated. But anyway, so this is last year's exam 2 in speech. So you can use CAS calculator. So if you look at those type of question, the question last year, by the way, is a difficult exam. Okay, so there's lots of TS for the special exam 2. Was very low. Average was very, very low. Okay, 75%. If you get about 75% correct, you would be A+. That's how tough last year the exam. So tomorrow, my guessing is exam 2 would be slightly easier. So this is last year second exam. The first question. However, having said that, the specialist exam is all. If you look at last 10, even 10 years, they are very predictable. The same type of question. The type of question are the same, but the last year, the only degree of difficulty increased. So it's still 6 same type of question, but every question there's A, B, C, D, E, F probably. A, B, C, D, they are relatively okay, but E, F, they all, everyone last year, E, F is very difficult. So therefore, there's a lot of blank. paper when I marked, oh my God, there's whole blank. Then people couldn't answer any of those questions. So if, for instance, if you look at the first question last year, so they always have a rational function. Okay, so ask for the asymptote and a point of inflection, or whenever ask you to sketch the graph. Now, this is relatively easy to do because you have a CAS calculator. Yes, any graph I can do it. Then copy them down as long as you're careful. And then you do have to show all the points, like a point of inflection, turning point, everything. So I've written all those sort of here, so that the skill is a very lots of skill you needed. But last year, if you look at first question D and E, if you look at the last question D, part D, they are a lot more challenging. They give you this, they change this rational function. All of a sudden they make this as a K, and they tell you this rational function, what K value, and this function only have 2 asymptotes. So now this becomes so much complicated. Those questions, it's unfamiliar question. People haven't seen this type of question, and lots of people don't understand this this rational function. The top and the bottom, numerator and denominator, both quadratic equation, power of 2. So therefore, this is improper fraction. Improper fraction, you can do long division. So in those equation, this rational function can return a constant number plus another sort of function. So therefore, if you have 2 asymptotes, so there's a plus something. So already we have this, for this function, we already have 1 horizontal asymptote already. So basically, for this question, we can only have 1 vertical asymptote. So once you have this idea, then this question can be done. If you have 1 vertical asymptote, so the denominator have to reduce by 1. So you cannot have 2 denominator. 2 denominator will produce 2 vertical asymptote. So then, because you already have 1 horizontal asymptote, so therefore the denominator can only be 1. So therefore, K equals 3/2, or K equals -5, or K can be -2 as well. So because the denominator can be x plus 2 squared. So there's 3 scenarios. So this question is very poorly done, almost 0. Okay, so the average basically is 0 from 2 marks. So basically, average is 0 mark. If you get 1 solution right, you don't get any mark. If you get a 2, you get a 1 mark. If you get a 3, you get a 2 marks. Hardly ever I see 3 solution correct. Luckily, you might see someone, very few people got a 2 correct, you get a 1 mark. If you only get a 1 solution right, or you write -2 or 5 or 3/2, you get a 0. Okay, that's how strict we're marking. And for the last question is the same thing. For this GX that has no asymptote, so basically first derivative cannot be 0, so the discriminant has to be less than 0. To solving this discriminant obviously is quite difficult. You have to do it on the CAS calculator. Take a while to type all of them in. Okay, so but it's also however, this D2 is still better than D1. The D1 is very difficult to do for last year. So this is last year, the first question. And then if you look at this is third question, again, the last couple of them are very difficult. Okay, so and the probability question is difficult as well. The very last bit is very difficult as well. So I don't think I'm just going to go through this. I might just show you this year's paper. Okay, let me have a look at this year's paper, the exam 1 paper. Okay, so I'm showing you the exam 1 paper I did. Let me have a look if I have this. Okay, so let me have a look at this. Exam 1 2022. Okay, so I'll just have a look at the solution. I did that solution. Okay, let me have a look at this. Okay, and here solution. Come on, there's a solution here. No, count. Okay, let's have a look at this. Okay, I'm going to show you this year's paper. Okay, so this year's paper, which is only 2 days ago. Okay, so Friday we did this. Okay, so this year's paper, as I said, we are a lot easier. Okay, so let me just make it bigger compared to last year. So this is the question. Let me have a look. Can you see this now, everyone? So Olivia, can you see this?
Yes, perfect. We can see that.
Okay, all right. So now there you go. So this is the first. Sorry, where's the first question? Complex number.
Perhaps next page.
Oh no, I'll open the wrong page. I'll open the methods exam 1 now. This is the methods exam. So now since we are in methods exam 1, I'll just talk about the last question. The methods exam this year is a lot easier. Okay, so however, the only last question is a little bit interesting. So both exam 1, exam 2. So methods is already out. The exam 1 question is the last one, and also the second exam, last one, is both they run in the same theme. If you look at the question, they didn't give you fx. They just say y equals fx, but they give you the area of this ak. So they give you ak, the function is k sine k. So simply you do have to understand that this equation. So ak equals integration of fx. Now, therefore, I forgot to mention this. So for those people, you often people ask me this type of question: is the kids doing methods and specialists concurrently? People doing special and methods concurrently at the same time, then those kids will benefit doing methods. Again, this is in specialist maths, so we're talking about a fundamental theorem. So if ak equals integration of fx dx, then derivative of this fx, fx is derivative of this ak. So this is what I did last Friday when I initially set sub these things. So wrong, I quickly rub them off. Okay, so I quickly realized this derivative of this ak equals fx, then f pi over 3 equal this. So this concept is the fundamental theorem of calculus. We heavily mentioned in special, but you hardly ever, no one would mention this in methods. Only good students will see this because ak is integration of this fx. Therefore, derivative of this ak equals fx. People can think logically. If the smart kids think logically, they will get that equation. But if you learn specialist maths, this is very automatically, okay? So because we mentioned fundamental theorems so many times. So if ak is integration of this fx clearly equals derivative of this fx or ax. So there you go. So this question is very easy to do. So, and funny thing, the second exam last question using this theme as well. Okay, so there's two paper, 2 question. If you do specialist maths, methods students will benefit. Okay, so this is the beauty. Okay, so now we might just look at the final minute. We just look at the specialists. Oh, sorry. Oh, can I not show this anymore? Share?
You can.
Okay, no, I'm just I'm just going to share exam solution. Let me SM. Okay, so just 1 minute. I'll show you how complicated. Maybe the time is up. Just hold on. Is that a? Oh, is that a? Okay, just hold on. Let me just show you this. Share. Oh God. Yeah. Okay. I don't know. Is that shareable? Okay. So. Oh God, I can't find this.
It's okay. Maybe I can share from my side.
Okay. It's here.
Okay, great.
It's here. Can you see this now?
I can see that.
Yeah, you can see this. Okay, so this is specialist maths. Okay, so now this is the last question this year. Okay, so if you look at this last year, this year's last question is a lot easier. They're only talking about the integration of secant square. But that's so simple. So if you recognize this is a tangent derivative is secant square. The only trick they made in the last question is you have to work out tangent the pi over 12, because we know tangent the pi over pi over 3, pi over 6, we know the pi over 12 is nobody sort of remember this, but there's so many different ways. It's 2 different ways you can do it. You can using double angle formula to work out a tangent of pi over 12, or you can using the pi over 12 is pi over 3 minus pi over 4, compound a tangent angle to work out a pi tangent pi over 12. So you to work out this value, which is square root of 3 plus negative square root of 3 plus 2. So that's the only trick they played last year. But if you look at the year, this year, if you look at the last year paper, they're a lot harder. So look, this is this year's paper, not very long, and you can simply do a couple of steps. So this is question 9, second last question. How many steps? Not even 10 steps, you're done. But if you look at last year's paper, you need a lot more steps to do those questions. And this one, a lot of people didn't get number 8 question. You will play, this is a hard one. A is v dv dx. So, but still relatively simple to me, okay, as compared to, that's what I'm saying, okay? So I don't know, the timing is up, so is anyone have any question? Okay, also, I mentioned the geometry, sorry, the vector proof. So this year they come up with this one. The vector proof, let me show you the vector proof question. Very simple vector proof. Number 6, okay, so this is a vector proof question here. If I make it slightly smaller, okay, you can see this is a vector proof to prove this angle is 90 degrees, but it's very, very simple. So very durable. So not many lines. So 1, 2, 3, 4, 5 lines to prove this. Okay, so it's still relatively simple. We do have a vector proof question. Don't come up very often, but this year they come up. Now, is any other questions? If anyone want to ask any questions, otherwise. I might just give back to you, Olivia.
Thank you very much, Mr. Wang. I think for me, those questions are pretty difficult. Maybe the students or parents from, from our side, we don't have too many questions to ask.
Excuse me.
Yes, great. With that.
So can I ask something?
Sure. Go ahead.
Yeah, so I just want to ask, would you still recommend the physics students doing SPECH next year?
Without a doubt, will benefit, yes, but it's less beneficial now because the dynamic is out. But it's still benefit. The kinematic is still there. The kinematic, those when we talk about the physics, A is always constant. So then those type of question in SPECH will still will do it. But we concentrate on, in SPECH, we concentrate on acceleration is not constant. So therefore, A is changing. So we're using derivative to, anti-derivative calculus to do it. Definitely, without a doubt, physics is, yes, will benefit us. Will be beneficial for the SPECH.
Okay, and so another thing I want to ask is for the bound reference notes, would you prefer students to make them by themselves, or so maybe bring in the booklets gave by their people, or they're going to buy like the notes that is printed by other organizations?
No. But by yourself is the best. So to be honest, my top students don't even have notes; they just took a book because. You don't have time to go through any notes, and so I currently teach specialist maths. What I did is I have my own notes, every chapter notes. So I cut paste total 30 pages, which covers everything. I think I covered every content of specialist maths that are emailed to my students. I say, look, this is your base of your bound reference.
到了，他说这些我都收过了，你不用担心。
Sorry.
现在我坐下来等医生来喊我们。
Hello. Sorry.
I just muted this person.
Okay, sorry. So that basically this, I told my students there's a 30 page of my notes is your base, but then if you want to add something, you add your stuff. Simply, you don't have time to read, to check your bound reference. Maybe your one formula you've forgotten, but you have a formula sheet. Just occasionally, I agree. Some of them are not on formula sheet. For instance, if you panic, you all of a sudden forgot how to work out the vector resolute formula. So then you have a boundary reference, open that up. Okay, a vector, how do I work out vector resolute? A times B hat and times B hat. So you quickly look at the formula, then you can do it. So that's the only thing you look. There's no way you can find a boundary reference, find a similar question or whatever. Some people bound the entire sort of 5 years of trial paper or whatever exam paper. They hope there's one question similar. Yes, they are similar, but you don't have time to find, even there's the similar question, you don't have time to find one. It's impossible to spend too much time on bound reference. Seriously, bound reference to me is basically is nuisance. Why do you need it? And to download a commercial sort of bound reference, 100 pages, pay for it is totally waste of money and time. That's what I'm saying. Okay.
I see. So you're saying that basically you are giving your students a 30-page.
I give them a 30-page as a base, but if they want adding anything, so then they can add. So I give them a PDF, sorry, the words file. Okay, so they can edit it. Okay, so basically they can add in another few pages of stuff. So, and some kids actually did it, and I know some of the students, they did their own bound reference. They put their own notes. Okay, so, and also the easy way to do it is that every chapter review, the textbook, which textbook you use, you photocopy the chapter review, the content. And they cover every basically formula, whenever. Then if you want adding other stuff, you can add it. Okay, so I do agree. Some of those, for instance, the specific talking about a specialist maths, we're talking about those inflow, outflow, those type of question. But some people will never remember this. So dx dt equals inflow rate minus outflow rate. They never remember this formula. So so how do I work out right hand side? So it's the inflow concentration times rate of flow rate. They never remember this. Some people. Okay, so then I said, look, you write this on your reference book. So then once this question come up, you quickly open this up. This will help. Yes, without a doubt will help. But if you write 100 pages, my God, the 99 pages is useless. Maybe only one is useful.
I see.
Yeah.
And for the CAS calculator, have you been heard anything like maybe Casio and TI Inspire is about to release their latest version of the calculator next year?
I'm not familiar with Casio because I have used the Casio, but I haven't used the Casio. The other Inspire, the TI Inspires already this year is they have the blue color one is very. You download the latest software, the operating system, they can do whenever. So some people, I'm not very advanced in CAS calculator. Some people writing, and also I know some school writing the program, the teacher writing program, students download the program. For instance, like again, the talking about a vector resolute, there's a formula. Okay, they put it into the CAS calculator or do the integration. For instance, some of the integration, they put it in. For instance, they do the curve length. Okay, so let's say parametric equation, so dx dt square plus dy dt square and square roots, then parametric, and they have this formula set up. You only have to put x and y into it, then the formula they can do it. You can do this. There's a lot more very powerful tool, this CAS calculator. You can writing those programs. The only thing I actually personally don't recommend any of my students doing those programs, because any program you write, they always have some bugs inside and also a limitation. Just give you an example. So some people write a program called linear equation. We give you 2 points, you write a linear equation. But what if those two linear equations, those 2 points are vertical? Then the gradient become undefined. Then the calculator will play around, and then you're panicking. So every program has their limitation. So if you're talking about how powerful this, yes, it's very powerful. But I personally just using this as a basic tool. So whenever if you want to do calculus, integration, I do integration. If you want to solve equation, I solve equation. I don't do any fancy stuff.
I see. So you're saying that TI Inspire is better than Casio, is that correct?
No, I can't make this judgment because however, TI I have seen you can write many powerful programs. But I guess TI, the other case, you can write this program as well. But I haven't, because our school using TI, so I went to those TI conference website. I've been a couple of times conference. Every time they introduce a new program, it's funny. Every time in the conference, I pinpoint their limitation. I give them the scenario that program doesn't work.
I see. Thank you. That's what I want to ask. Thank you very much.
No worries.
It seems that the topic is becoming that whether or not we should rely on our brain or working out, or whether or not we should rely on the calculators more.
I'm old-fashioned because I'm old, so I'm old. Concentrate on understanding. The calculator is to help you to do question quickly. But I'll be the first to admit. My students, a couple of my students, they are so much quicker than me on the calculator. They actually write their small little program, and they know all the fancy button they are do. But I can't compete with them. But they tend to be the students tend to be very good at the computer and the calculator. Anyway, okay.
Yes.
Any other
questions from different students or parents?
Yeah.
Yeah, if we don't have any questions more, maybe, we are going to have a break now. Thank you very much for your time, Mr. Wang, and thank you for everyone to attending the seminar. If you do have further questions, then you can send email to us.
Yeah, okay. Olivia, I will send you to those link. One is the Nelson presentation of VCE Specialist Math Change, about 1 hour in YouTube. The other one is the website for the other teacher wrote, I think it's VCE Maths. Okay, so I can send that to you, link.
Thank you very much for your generous sharing.
Okay, all right. So if
wish everyone have a good night, and looking forward to see you the following week.
Okay, all right. So I might just get out of this system now. Okay,
sure. Thank you. Good night, everyone. Bye.
Thank you. Bye-bye.
Wait, thank you.
How do I get rid of this?
And meeting.
Leave. Okay. Okay, am I left? Oh my God, this helps.